Okay, so today we're going to talk about how to utilize CAD when programming. Because last year I got a lot of what's the dimension of this, what's the weight of this, what's the length of this, where's the center of mass of this, and that's all going to be on the CAD, and it's open for everybody. And this is the reason that I've been saying everyone, including the programmers, needs to join the CAD team so you have access to all this. So during the on season, our CAD folder is going to look like this. This is 5411's CAD folder for charged up. So you notice you have the full robot assembly, and then each subassembly has its own document. For this one, we're going to use the scoring document. That's going to be your arm. So here we have our double jointed arm. Sometimes when you open a document, it might not show up. In that case, go to the left over here and click versions and history. This is running kind of slow. And you might see that there's a separate branch. So here, this is the main branch for it. But you'll notice there's a couple other branches that we've used, and it usually defaults to main. And you'll see in main, I don't think there's anything. Or if there is, then it's not right. So yeah, there's literally nothing in main. So here, double jointed is what we want to do because that's going to be our final assembly. Now we have this. I am actually in the wrong document. So no, I'm not supposed to be in the scoring document. I'm supposed to be in the robot assembly document. So the robot assembly is going to have basically what it says, the robot assembly. Also here, your shaded without edges is going to be your friend. It will improve your quality a lot when you are dealing with big assemblies like this one. It's a web-based thing, so it's gonna take a little time to load with complex documents. Anyways, it's taking longer than usual on this, honestly. Okay, there we go. So here on this one, I have a side view of the grid that you can open up if you need it. So now what we're going to do is we're going to talk about how to take dimensions. So let's say you are programming the arm and you need to know, hey, what is the dimension of the first stage of the arm? Well, what you can do is you can go into, if you don't want to go into the full assembly because it's so slow, you can go into the scoring, but we're gonna go back into the scoring because it's going to be faster, and then we'll come back to the full assembly when we need it. So now that we're in the scoring assembly, if we want to say what's the length of this first stage, there's two ways you can do that. If you need the length of the bar, all you have to do is click on one end of the bar, and then without clicking shift, you can click on the other end of the bar. And then once you have those two selected, in the bottom right, you'll notice here parallel distance. And it's going to give you the distance between the two, or you can click show measure details and it'll give you your parallel distance, your minimum distance, and your maximum distance, which in this case should be the same, but it doesn't look like they are. No, this is longer because it's diagonal across. But here your parallel distance is what you're going to want. Now, when you're actually moving around to get those assemblies, there's three main controls you need to know. The scroll wheel on your mouse will be to zoom in and out. The right click, if you hold that down, it will let you move and rotate the assembly. And then left click is how you actually select items. So you can use those three. You can zoom in, you can rotate to select certain things. If you want to point, just make sure you click this little dot. You want a line, make sure it's selecting a line. You want to face, make sure it has the face highlighted. And then when you're done selecting stuff, you can either click on it again and it'll unselect it, or you can click on the blank white space and it'll deselect everything. With Onshape, it is a continue selection program, I think is what it's called. So you don't have to click shift to select multiple things. So sometimes that can get confusing because that's what a lot of other softwares do. That's not what Onshape is. If you want to get the dimension between the pivot points, which is probably going to be a little bit more useful in a case like this, you'll notice in the assembly, these can move, and they're designed to move. They move along the hex shafts. So what you can do is click the circle, click the edge of this circle of the bearing, and the middle of that bearing is going to be right in the middle of the hex shaft. And you're going to go ahead and do the same thing on this bearing. Now you'll notice center to center distance is 20.25. Now when you're measuring circles, center distance is what you want. Sometimes though, they won't line up perfectly. And you'll notice that in this case, the x dimension is 0 because they're in the same plane. If they weren't, this x dimension wouldn't be 0. And you'd have to account for that in your calculations. Here it is, so you don't. But if you do have to, it's just basic Pythagorean theorem because you're giving your y distance and you're giving your x distance. And your center distance is 20.25. And that's going to be your length measurements. If you need to find an angle between two things, you just, that's going to be faces. You need to select faces for it to work as an angle tool. So here, if you say want to measure the angle between these two arms, you'd select the bottom face of this arm and the bottom face of this arm. You can select the top face. It doesn't really make a difference. And then here you'll notice it gives you the angle. It's 83.409 degrees in its current configuration. Now, right now, the angle is probably not particularly useful, but that's how you would get the angle. You also have the total area if you ever need that, but that's how you're going to get the angle of it. Now, if you notice that the normal controls are being a little weird, you can also use the view cube at the top right here to have more precise controls over your document. Now, we're going to go into the final robot assembly because in the robot assemblies here, whenever you're programming, you have certain set points that you need to hit, right? In CAD, we have those set points already made. If we go to we'll go ahead, first thing remember is going to be to set it to shaded without edges. That way we can increase performance a little bit and go to the right view. On this right end, you'll notice that there is going to be a named positions tab. If you click on that, here we have all of the named positions. If you right click on one of these, click apply named position, it will change the robot to reflect what that position looks like. And you can use this to measure when it's in top cone score, what's the distance between the bearing, between the pivot point at the front and the very end of the intake. And here you say your distance, you're probably going to want max distance on this one, is going to be 68.49 inches. If you want just the y distance between them, then that's going to be 67.07 inches. And that's going to be true here if you want the resting configuration, apply name position. I think this is the old resting configuration that we had at the beginning of the season. Yes, it is. But the point still stands. So here, if you want to go to the Cobra position, which is what we usually use as our resting position now, right click and click apply. Now you don't ever want to edit the name position because that's going to mess up the set points we have. And in general, you should never be editing the CAD. You should only be getting the measurements that you need. If you need something edited, come talk to one of the CADers and we'll get it done for you, just so we can preserve the standards of what we're doing. Something else that may be useful for a CAD that you might need should be something like gear ratios. You can get that on CAD. It's a little confusing. We're going to have that documented in the CAD journal though, and I'll go over that some more in the Ed app and how that's going to work for y'all. All the important measurements can be documented there, so you don't have to go to the CAD every time you do one of those. But that's going to be how you're getting basic measurements, so you can open up the CAD and do that yourself. If you're not on the Onshape, let me know so I can get you added and you have access to all of this. You can rewatch this video anytime you need, however many times you need when you need help. If something's not working for you, come talk to me or come talk to one of your Met captains. They'll be able to get you sorted. But the biggest thing is don't make any changes. Any changes you make will mess with the standardization, the organization, and the precision of what we've already made. If you need something changed, come talk to me or talk to one of your team scatters. But that's really the basics of what you need to know just to program a robot based off of CAD.